Yes.
Okay.
Yeah.
Um, we are going to develop this OData services using SAP NetWeaver Gateway and Gateway Service Builder in SAP. But before we talk about SAP NetWeaver Gateway or SAP in general, let's see what OData is and what RESTful API is and what is the connection between OData and RESTful API. Okay. So um, these are definitions of OData and REST. OData is an open protocol which is used to create RESTful APIs. So OData is the means to create RESTful API. REST means representational state transfer. It is a kind of software architecture for World Wide Web. So OData is one way to achieve RESTful APIs. One of the best ways to achieve RESTful API. So, in short, OData is a means. It's one kind of way to achieve RESTful API. So, since we are talking about OData and RESTful API, we will see what the RESTful API means. Let's say when we develop a service, how can it be qualified as a RESTful service? So basically, there are several tenets. So basically, there are several tenets and several constraints in order a service can be a RESTful API. Okay. Um, OData is initially introduced by Microsoft, and now it is being used for web applications and mobile applications very widely across the industry. Okay. Let's see what the REST means. Okay. So REST means representational state transfer. This software architecture is explained through two tenets and six constraints. Let's see what are all the basic principles of RESTful APIs and what are all the constraints in order a service to be qualified as a RESTful API. Okay, the basic tenets are going to be one, it is resource based. Two, we are going to manipulate these resources through representation. These are two basic tenets of RESTful API, and there are six more constraints by which a service can be qualified as a RESTful API. So the constraints are going to be uniform interface, stateless, cacheable, client server, layered system, code on demand. We will see these two tenets and basically tenets means principles or philosophy behind RESTful APIs, and we will see in detail what these tenets and what these constraints are. Okay. So when we talk about RESTful APIs, everything that we mention in RESTful API is a service, is a resource. So basically, one second. So RESTful API is a kind of web service. It is when you talk about RESTful API in terms of resource, we are comparing RESTful versus SOAP. Whoever has knowledge on web services and all, they know, SOAP pretty well. But even if you don't know, don't worry much about it. We are going to discuss about it. So let's say when we compare REST versus SOAP, so here it is resources versus actions, nouns versus verbs. So typically, in REST, let's say employee is a resource, product is a resource, customer is a resource, sales order is a resource, sales order item is a resource. Let's say employee is a resource, customer is a resource, Sales order is a resource. Product is a resource. As opposed to, in SAP, we have methods to get an employee. So similarly, get customer, get sales order, get product. So when we are talking about RESTful APIs, everything we see in RESTful API or OData is a resource, as opposed to SOAP, where everything is a verb or everything is action based. Okay, so we will see hands-on when we talk about OData APIs. I will show you an example, but just for theory purpose, everything that we see in RESTful API is a resource. And these resources are uniquely identified by URIs. URL is one of the URIs, okay? So we identify these resources. We identify these resources in RESTful API through URI. URI means unique resource identifier. URL is one form of URI. So let's say if we go to browser and if we type google.com, it goes and get the resource. It gives you the web page google.com. So URL is pretty popular. So we see every day. Whenever we go to certain sites, we get the that web page through URL, Uniform Resource Locator. So we identify resources in a RESTful API through URLs. It is one form of unique resource identifier. So the second tenet is representation. Whenever you request a resource from the RESTful API, you are not actually going to get the resource, but you are actually going to get the representation of the resource. Let's say if the employee information is stored in SAP database, when we request for the resource, when we request for a resource called SAM, we are going to get the representation of that resource. It does not send you the actual database. It just send you a copy of that particular employee called Sam. So typically that representation is going to send to the client in XML or JSON format. Okay, so these are the two basic tenets of RESTful APIs. One, it is resource based, and these resources are identified through URIs, unique resource identifiers. URL is one form of unique resource identifier. The second one is whenever you request a resource, you actually get the representation of that resource. And that representation is received in either in XML format or JSON format. We will see what is the difference between XML and JSON format. XML has been for a long time in order to communicate between two incompatible systems. XML is being used as a medium, but of late JSON is getting pretty popular in terms of web applications and mobile applications. The reason being, when you when you represent the same kind of, let's say we are talking about an employee information called Sam, right? Let's say if we represent SAM information in XML versus JSON format, the file size in JSON format is at least 30 to 40% less than when it is represented in XML. Okay. When we say XML versus JSON, if the same information is represented in XML format, let's say if it take 100 bytes, the same information can be represented in 60 bytes. Especially when you are, accessing information on mobile and all, every bit counts. So there is a popular trend. Um, People are moving to JSON format whenever you are building web applications or mobile applications. Okay, so these are the basic two tenets of RESTful APIs. One, it is resource based, and the second one, it is representation. In resource based, everything we see in a RESTful API is a resource, and we are going to identify these resources through URIs. URL is one form of URI, okay? And the second one is representation. Whenever you request a resource, you actually get, the client actually get a representation of a resource. It don't actually get the resource itself, but it will get the representation of that resource. The representation will be sent to the client either in JSON or XML format. So we now discussed, what is the difference between XML and JSON format. When you show the same information in JSON format, it is less in size. So in case of web applications and mobile applications, people are moving and people are preferring JSON as opposed to XML format. Any questions so far?
Sudhir,
Uh-huh.
can you elaborate the representation when we access REST resource through URI? It
Uh-huh.
is going to give representation of the resource, not the resource, right? So, I
Yeah.
mean, what is the exact difference of resource and resource representation from the
Yeah, let's say when
retrieving
you
data from any database when we normal traditional way when we retrieve data?
here, RESTful APIs are going to be used in the client server architecture. Let's say when you request for information to the server, right? Let's say you ask for employee Sam. So it actually send you the information
Mm-hmm.
in XML or JSON format. But let's say after you have requested, right? Somebody might have changed that resource,
Mm-hmm.
right? You are not getting an exclusive copy for yourself. You are just getting a copy of that employee. But after you have requested, that resource might have been changed. You actually got a copy of that employee. You actually did not get the database, object itself, right? Does it make sense?
Mm-hmm. Uh,
You
so.
may, let's say, if employee object has like, 10 or 20 attributes, but let's
Mm-hmm.
say when we define a resource as part of the RESTful API, probably we might have just defined it as 10 attributes, right? When you
Okay.
request for that information, you will just get that 10 attributes at that point of time you requested that resource. The database
Okay. Yeah. Got it.
representation might be, the database representation of that employee might be different, but you actually
Okay.
got just a copy and just part of
Mm-hmm.
that resource as a representation.
Okay. Yeah. Got it. So this is defined when we define the resource. So we define the attributes which only we require,
Yeah.
right? So yeah, I got it.
Um, any more questions? Okay. So we have discussed about two basic tenets. Now we will discuss about different constraints of these RESTful APIs. There are namely six constraints. One is uniform interface, and the second one is stateless constraint. Third one is cacheable constraint. Fourth one is client server constraint. fifth one is layered system, sixth one is code on demand. Let's say when you define a service, in order it to be qualified as a RESTful API, it should follow the first basic tenets and at least first five constraints. Then only you can, that service can be justified as a RESTful service. The sixth one, code on demand, you don't need to follow that constraint. Okay. Let's see what are these constraints means in detail. So let's see what the uniform interface means. The uniform interface constraint defines the interface between client and server. Let's say, actually, as I told you, the RESTful architecture is a client-server architecture. The uniform interface defines an agreement between client and server. As long as, that agreement is followed by both client and server, you can you can decouple them. You can decouple the UI, you can decouple the backend business logic. Both of them can evolve independently. As long as both these pieces stick to the to particular agreement, they can both independently evolve. Without concerning about each other. I will show you what the uniform interface means. So the guiding principles of this uniform interface is, one, it is resource based. Whenever you create a, RESTful API, all the things that you see in that RESTful API is going to be a resource. Okay. So, and as we talked about, each resource is identified by unique resource identifier, and whenever you request for a resource through URL, you actually get the representation of that resource. Okay, you will receive that representation either in JSON or XML format. The second guiding principles is manipulation of resources through representation. So when you get a representation of a resource, you actually have enough information to manipulate that resource. Let's say when you request for information about an employee called Sam, that representation hold enough information from client. It can be sent to the server and it can update that resource. So manipulation of resources is going to be done through representations. That is the other guiding principles. The third one is, um, we use HTTP spec. We use HTTP methods for RESTful services. We will see what those, let's say if we wanted to create a resource, if you wanted to get a resource, if you wanted to delete or update a resource, you are going to use HTTP methods. Okay. I will show you in the next slide what are all those HTTP methods which will be used to do CRUD operations, create, read, update, delete operations. Okay, so this is the uniform interface constraint. Basically, uniform interface is an agreement between clients and server. Uh, as long as these two parties agree to that agreement, both can evolve independently, without bothering each other. Okay, the guiding principles of this uniform interface is, one, it is resource based. The second one is we are going to manipulate these resources through representations, and we use HTTP methods uh, to do all the CRUD operations, create, read, update, delete operations on the RESTful APIs. Okay. Let's say what are all the HTTP methods. Okay. Let's say if I have a resource, right? How to create a resource through HTTP method post. If it creates the resource, the return code is going to be 2. Okay. If it is, if you have any errors, it will, it will be something which starts with not 2. Okay. So we use HTTP methods in RESTful APIs. Okay, for 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 read we use HTTP method. Okay, the following are the CRUD operations. This is the corresponding HTTP method. Okay, get is the HTTP method in order to read a resource. Okay. Similarly, if you want to create a resource, we use post. If you want to update a resource, we use HTTP method put. Let's say if we wanted to delete a resource, we use HTTP method delete. So any successful operation would give you written code which starts with 2. So anything other than 2 is you encountered with a problem. Okay. I will show you all these details when I show the OData service. But for now, just get as much information as you could. So now we have discussed what is the uniform interface constraint. The uniform interface constraint is explained through uh, the following guiding principles. One, it is resource based. Everything we see in RESTful API is a service. Okay. These, everything we see in RESTful API is a resource. These resources are uniquely identified through URLs. Okay. Whenever you request a resource, you actually get representation of that resource. Okay. And that representation is either in JSON or XML format. Whenever whenever we are manipulating these resources, the client has enough information to manipulate that resource, and we use HTTP spec or HTTP methods to do all the CRUD operations, create, read, update, delete operations. We use HTTP spec or HTTP methods. So these are the HTTP methods which are equivalent for read, create, update, delete. And whenever the operation is successful, you receive HTTP response code starts with 200 or 2. If you encounter with any problem, you receive a non-2 written code. Okay, that is about uniform interface. Any questions? Um, okay, we will move on to the next constraint. It is stateless. It is stateless. So when I talked about RESTful APIs, I told you it is client-server architecture. Okay. Whenever, from client, whenever you request a resource, let's say if you are requesting an employee called Sam, the server just receive that request and send you the response back. After, after server sends you back the response, server doesn't even know that you exist. Okay. Server doesn't store the information that you have already requested the information SAM. Let's say if you just send a message back saying that, okay, just update this resource. I don't know what this resource is because I have already requested it. Uh, and if you assume that server knows that, you have already requested, it does not work that way because it is stateless. Whenever you send a request, server will send you back the response. That's it. Server does not even hold any session information, any user related information in server. Okay. So that is about the stateless. So uh, so each request should contain enough information to get response back. Let's say if you just say that, okay, give me employee, the server does not know what employee it should give. So because it is stateless application, you should pass enough information to get the response. So one downside with statelessness is, the network traffic is going to be more because you are going to send more requests because on the server side, it is not going to store any information. So there might be repetitive information that you are going to request. So that is the downside with statelessness constraint. But the bright side of statelessness is you are going to completely, decouple the server from storing all the session information and all. So to a greater extent, the servers are going to be relieved. Whenever they receive a request, it just sends the response. It does not care about storing all the information about who has requested what. So in a great, it gives you great performance at the server side and it is scalable. Okay, that is about the statelessness constraint. So any questions on these constraints before we go to the next constraint? Okay. The other constraint is client server. The REST representational state transfer is a client server architecture. Um, so the client is going to send the request, server is going to look at that request and send you the response. The uniform interface constraint that we talked about is an agreement between the clients and server. As long as that uniform interface constraint is followed by both client and server, both client and server can evolve, independently of each other. Okay. The separation of concerns means that, let's say, now we are developing in SAP space, now UI5 or Fiori is the user experience, right? Let's say at later point of time, if it is being replaced with some other UI framework, at that point of time, you don't bother about, you don't have any concerns about the backend. You can simply replace the front end with some other technology. Since it is a client-server technology and it is decoupled through uniform interface constraint, you can change. Let's say if you wanted to change the UI, you don't need to bother about the backend. The backend stays same as long as the new UI framework understands these RESTful services. You can just change without touching the backend. At the same time, even the backend, without, let's say, if you wanted to change the implementation without changing the agreement, you can just change it because the client only knows, the service metadata and all. The client only knows the uniform interface agreement between the client and server. As long as it is not affected, the server can change the implementation details of the service. Okay. So in short, the clients are not bothered about how the data is being stored, how the data is being retrieved. And on the backend side, it don't bother about how the data is being represented in the UI. Okay, so both backend and front end can evolve, can be developed, without touching the other side. Okay, so um, so basically, the servers and clients may be replaced or developed independently as long as the uniform interface constraint is followed. Okay, that is the benefit of client-server technologies. So when you compare it with other UI technologies in SAP UI space, let's say WebDyn Pro ABAP or WebInfo Java or BSPs, these are all server-side technologies. So SAP is a big shift. I mean, SAP UI5 and Fiori is a big shift in terms of, I mean, these client-server technologies from server-side technologies which SAP is using right now, WebInfo ABAP or WebInfo Java. So, I mean, when we discuss about, I mean, when we write the SAP UI5 applications, we will see, I mean, how every constraint is followed. Okay. Any questions so far? Okay. Um, okay, let's go to the next constraint. Okay. The other one, the next constraint is cacheable constraint. Basically, I mean, the server responses can be cached on in the browser sessions. What it means is, let's say if you are going to I mean, request a master information, let's say as part of your application, you are going to get all the states in US, right? Let's say you can store that information in client or in browser. And I mean, let's say if you want to, I mean, if you are requesting that information again from the server, I mean, since that response is cacheable, the browser is going to cache that resource. Instead of send next time, let's say whenever, I mean, the browser or client asks for states, instead of sending that request to the server, it just gets the data from the cache. So you can reuse the data by caching it. So you can decrease or you can, I mean, reduce the network traffic. So basically, I mean, when we develop an application, let's say if we know certain information is not going to be changed, we are going to cache that resource. We are going to, I mean, whenever server is sending the data or response back to the client, it says that, okay, cache this resource because we are not going to, I mean, this data is not going to be changed. So cache that resource. So whenever the client requests for that information again, instead of going to server to get the response, it uses the data from the cache of the browser. Okay. So the downside of this cache is, I mean, let's say if information is changed on the server, if you are reusing the data from the browser cache, you are going to end up with stale data. That's why you need to have a good cache strategy. I mean, whenever we develop applications, we see what kind of data is not going to be changed very frequently. Basically, master data and all, it is not going to be changed frequently. So we say that, okay, cache this resource because we know for sure, or we know for most parts, I mean, this data is not going to be changed. So we are going to send, I mean, the response saying that, okay, cache this resource. So well-managed caching, I mean, gives excellent results because we are going to reduce the network traffic and we are going to use the data from cache um, instead of sending it to the server. Okay, that is about the cacheable constraint. Okay, the next one is a layered system. Let's say if you develop the OData service, right, or RESTful API, if the client requests for the information or resource from the RESTful API, there might be several layers between the client and the actual business systems. Okay, so the client should not assume whatever it is talking to is not actual business system. Okay. Um, So in order to explain this constraint, I will show you, okay, can you see the picture? So In SAP NetWeaver Gateway, there are different kinds of deployment options. One is the central hub deployment, and the other one is embedded deployment. Okay. Um, so most of the clients, even SAP is suggesting to the clients to go with the central hub deployment. I will explain what the central hub deployment versus the embedded deployment is. Okay. So in the central hub deployment, this is your, the bottom part is your business system, be it as CRM, be it as, HR, be it as SRM, be it as BW. This is your business system. But, the OData services that you develop are going to be in the business systems, but they are going to be registered in the, gateway systems. Okay. The actual, sorry, the actual uh, business systems where we develop OData is, the bottom part where, ECC, CRM, BW, so all these systems, we develop the OData services here, and we are going to register that service in the gateway server. So when the client requests for data, it requests data from the gateway server. From the gateway server, through an RFC connection, it gets the data from the corresponding business systems. Okay. Now the client should not assume that, the client is communicating with the gateway server, but the actual OData service is getting data from the business systems. So this is what it is called layered system, right? So the client is communicating with another layer in between before it gets data from the business systems. So, whenever you are writing a RESTful API, the client should not assume it is directly talking to the business system where the service is developed or where the data is. You might have several layers in between client and servers. There might be a lot of independent, intermediate software or hardware systems um, in between the client and server. Especially in case of, SAP NetWeaver Gateway and OData services, it is true because most of the clients are going with the central hub deployment where our OData services are going to be developed in the backend business systems, but they are going to be registered in the gateway server, and the clients are going to access that services through gateway server. So it is going to directly talk to the gateway server, and the gateway server is going to talk to backend business systems through trusted RFCs. Okay. So, this is about the layered approach. Since we are discussing different deployment options in SAP NetWeaver Gateway, we will look at the embedded system, embedded deployment options, where the OData services are developed in backend systems and they are registered in the backend systems. In this case, the client is directly going to talk to the business system. In this case, there is no intermediate software or hardware systems between the client and server. But it should not be assumed in RESTful APIs that client is directly talking to. There might be chance that you are directly talking to the server, but in most cases you are you are talking to some intermediate software or hardware system, uh, which is not actually the real business system. That is about the layered approach. Okay, by having this layered system, let's say the backend business system can be replaced. The in between. As long as it provides the correct information, it can be replaced with some other information, some other system too. So basically the scalability will be more. There is more independence for the system maintenance and all. So that is about the layered system. Okay. So it improves scalability. The layered system constraints improves the scalability feature. So by complying with these basic tenets. So by complying with the basic tenets, resource-based and representation, and these 5 constraints: uniform interface, statelessness, cacheable, client-server, layered system, when you write a service with these constraints and with these basic tenets, it is a fully qualified RESTful API. It is well implemented RESTful API. Okay. So, when we are discussing, why we are discussing RESTful API? Actually, we are working on OData, right? OData is just a means for the RESTful API. Actually, OData is the RESTful API. Okay, it is one way of achieving the RESTful API. Okay, that's why we are, pressing more on RESTful API tenets and constraints. Okay. Any questions before I show how the OData looks like and all? Any questions so far?
In layered approach, when we have
Uh-huh.
central hub gateway, is it where multiple backend business systems are connected and different clients make calls to different systems, right?
Uh-huh.
So in this case, is it possible to define routing conditions at gateway level? Based on condition, it should route to business system A or business system B, like that.
Yeah, let's say if you develop one service in ECC, and if you develop another service in CRM, and if you develop another service in BW, when you register all these services to gateway hub system, you are going to mention which RFC, which trusted RFC connection it is going to use. In that RFC connection, it knows through that RFC connection, it knows to which system it is going to route to. Does that answer your
Okay.
question?
Mm, yeah, so, some extent. So actually, my question is, same. Let's say if there is the same resource exists in two different systems, ECC and CRM.
Mm-hmm.
So client is referring the same resource, same URI to the
Mm-hmm.
gateway.
Mm-hmm.
Uh, so in that case, I would like to put
Sure.
some condition in gateway to differentiate whether it should go to ECC or CRM.
Okay. Let's say you can have the same resource, but before you come to the resource, you should come to the service. As part of that service, you might have n number of services, n number of resources, but that service is, what decides to which system it go. Let's say if you have a OData service in ECC where you have employee resource, right? Let's say, okay, one second. Let's say you have a service called X, which has resource employee.
Mm-hmm.
It is developed in ECC. Okay. Let's say if you have another service called Y, which also have resource called employee, uh, which is developed in CRM system, right? So
Mm-hmm.
your URL is going to be something like this. Okay. URL to gateway hub system, let's say host name and port number of hub system. Okay. And my service is X, then I will call for employee. Okay. Employee one. Now in the second case, it is going to be the same host. You are talking to the hub system, right?
Yeah.
But the service is going to be Y, and the resource is going to be employee. Okay, so when you register this service, okay, when you register this service in the hub system, let's say you say that, okay, use trusted RFC to ECC. Okay, when you register the service Y, you say that, okay, use trusted RFC to CRM. So even when you request the same resource, it is going to be in different services, and with the service, the trusted RFC is bind with it so that it knows to which system it should send the information. The gateway system or the gateway hub basically knows to which system that service should point to based on the trusted RFC connection. Does it make sense?
Okay.
Um, any more questions? Everybody could, listen to, everybody could hear my voice, right?
Yeah, we can hear your voice.
Okay. Any questions so far what we have discussed?
No, no.
Okay. I will show you one of the OData surveys. So now you might have clear, a little bit understanding about, why we talked about RESTful API. So OData is one of the ways to achieve RESTful API. Basically, RESTful API is an architecture. It is like, it is, a software architecture style, but OData is means to achieve that RESTful API. That's why we discussed about RESTful API in detail, or just, to some extent. But the real thing is OData, right? So let's see. So there are lots of publicly available OData services. Okay, let's say odata.org. This is where you can get all this information about the RESTful APIs. It explains a lot. So whenever you have time, just go through it. It's called odata.org. So it is open protocol. Lots of customers are using OData in order to build, web applications or mobile applications. So whenever you have time, go and check it out. So let me show you one of the OData publicly available OData services. Lots of clients, let's say Amazon, Apple, they offer their services through OData services. Let's say if you want to include Apple movies or Apple music in your website, they offer actually OData services, so you can build your web applications and you can include those links for the information sake in your website or web applications. So similarly, let's say most of these weather channels and all, they offer that information in OData services. Let's say if you have a need to use that weather services, you can just consume that OData service provided by those weather channels and show weather information in your area whenever you are building a mobile application or web applications. So there is a great popular trend moving to OData and RESTful APIs. So most of the web is dependent on these RESTful principles. Okay. So this is the URL, reference services. As part of the OData organization, they have provided, reference services. We can go and look at it. Let's see, we discussed about lots of, constraints, basic tenets and all, right? We will see, in hands-on when we see this OData services, right? Okay, let's go to, this is one of the Northwind service, okay? So basically what you see here is, let's say if I say metadata towards the end of it, it just gives me information about, let's say if I say, so when I add, dollar metadata towards the end of it, I will explain later why you have to give the dollar symbol and all, but just remember for now, when I wanted to know what that what that service represents, I can just go and request for the metadata. So it gives me information about the metadata. Let's say if you see there is an entity, in OData or RESTful APIs, resource and entity is being interchangeably used. Let's say um, now we see an entity or resource called category, and the primary key on that resource or entity is category ID, and there are lots of other properties. One is category name, and the other one is description, which is of type string. Can it be nullable? Can it accept null value? No. Every category should have category name, category description. What is the maximum length of it? It has picture, which is of type binary. So when you request metadata of the service, it basically gives you all the resources, and it gives you information about that resource. Let's say now the resource or entity category has four properties. One is category ID, that is the primary key, and the second one is category name, which is of type string, um, and the maximum length of it is 15 characters, and the second property is description, which is of type string, and the third one is picture, which is of type binary. If you see the data types here, it is followed by EDM dot, or it is prefixed with EDM. EDM means entity data model. Um, Entity data model. So entity data model is the data model for OData services. Okay. So in ABAP you see character, and ABAP you see X string. Character is equivalent to string in EDM data type. X string is equivalent to binary in EDM data types. Okay. So similarly, you see an entity or resource called customer. Okay. It has customer ID, which is the primary key of type string, and maximum length of it is 5 characters. Similarly, company name, contact title, so entity, address, city, region, postal code. So basically, if you want to know about that service, you request for the metadata. As long as you get that metadata, you can build your UI application. Basically, when you look at a property, you know what kind of data it is, what is the length of it, and all. So this is, this metadata serves as the uniform interface between the client and server. As long as, this metadata is not going to be changed, the client does not bother about the implementation details. Let's say, so there are lots of entities, okay? Similarly, okay, one second. So there are lots of entities. So if you see, right? So I will look at the product. There is an entity called product. Okay, and you will have a collection of or entity set. Okay, if product is an entity, products is the entity set. Normally resource or entity is a single thing. Collection or entity set is, collection of those resources or collection of those entities. Okay, so if you see, there is an entity set called product, right? And if you see, so there is, so there is an entity called product. The primary key of that entity is product ID. It has lots of other properties: property, product name, supplier ID, category ID, quantity per unit, unit price, unit in stock, units in order, recorder level. It has lots of properties. Okay, now we have an entity called product and entity set called products. Basically, resource and entity is used interchangeably in OData or RESTful APIs. When we go to SAP OData services, we use entity and entity set. Basically, it is nothing but resource that we discussed. Okay, so we have an entity called product and entity set called products, right? Let's say if I wanted to get all the products, right? Up to this is the service name. Okay, this is how you request products data. Let's say if you want to get all the products, right? So these are all products, right? These are not in a readable format, but this is the JSON format. Let's say you go to the Chrome. Okay, Chrome has an extension called JSON extension for Chrome. I'm going to add this extension to my Chrome browser so that it will be displayed in a proper format. Okay, I'm adding this one to Chrome. So I say add extension. Okay. So now I have added this JSON view extension to my Chrome browser. Okay. Let's say if I request the same information. Sorry. Let me go. Okay, it is added to Chrome. Okay, let's say you will see this little symbol here. That is the JSON view. Okay, uh, this is, you see the little symbol here. This is Chrome extension. Okay, basically it put in a nice format. So if you see here, this is how JSON format looks like. I mean, there is nothing special about it. It is just key value page. Okay, it says, okay, my product, I mean, the entire thing that you see, I mean, in this curly braces is JSON object. It says that, okay, product ID is 1. What is the product name? Chai. I mean, the supplier ID is 1, category ID is 1, quantity per unit 10 boxes. In each box it has 20 bags. Unit price is $18. I mean, unit in stock is 39. So it just basically represent the information in the JSON format. I mean, there is nothing special about the JSON format. If you go and check in the W3 schools, you can get all the information about JSON formats. It is just, I mean, key value page. Okay. So basically this curly braces says that it is a JSON object, and inside you have key and value, key value, key value. So you will see all the details about the products. This is how you request uh, resources or entity set on a OData service. Any questions so far? Okay. Now I requested this information from the client. I don't know where the server is. I don't know the implementation details of the OData service, but I'm just getting the information. How do I know that, I mean, I can request products information?
Your voice is breaking.
Okay. Is it good now?
Yeah, yeah.
Okay. Um, Basically, I mean, we just know this service information through metadata. We don't know where this service exists. We don't know the implementation details of this OData service. We just know from the metadata what kinds of entities or what kinds of resources, what kind of entity sets exist in this resource. Okay, that is what the uniform interface is. And as we talked about, I mean, everything that we see inside a RESTful or OData is a service, I mean, right? So we have seen a resource or entity called product. We have seen an entity set called products. So this is how we request, I mean, products information. Okay, you just simply give the entity set name. We don't know anything about, mean, where this service exists. We don't know how it is implemented. We don't know how many intermediate systems in between client and server. Okay, that is abstract to us. But what is binding between the client and server is, I mean, the metadata uniform interface. Basically, when we see product, we can request the product's information like this. We don't bother about how it is implemented in the backend. We just know, from the metadata that, okay, a resource called products exists in the resource, so I want to see all that information. As a client, I don't bother about, how it is implemented, where it is getting the data from. As long as it gives me information, I'm fine. So that is the uniform interface part. That is, resource part of what we discussed. And if you see, it sends you the representation of this product. Okay, it did not send you the product resource. It just send you the information in JSON format. Okay. Um, so let's say if I want, one particular product, instead of, several products, I just want a product called 2. This is how you request it. Since we know product ID is the key, you just give that product ID, okay? So it just gives you that, single product. So this is how you request for resources. This is how you request for entity sets or entities, okay? And when we talk about the uniform interface, we said that, it uses HTTP spec, right? Let's see. So as part of every browser, you have developer tools. In Chrome, if you go to the settings, okay, and if you go to more tools, and if you go to developer tools, okay, so here we can see all the network going out of the browser, right? Let's say a request went for the product 2. If you see, right, so if you see the request URL here, I will paste it in the, okay. So if you see request URL, we said that, we request resources through URI or URL, Uniform Resource Locator. Okay, this is the URL. And we said that we are going to use HTTP verbs or HTTP methods in order to get the resource. We use, HTTP method called get. And the status code is, 200. And we discussed whatever it starts, if the response code starts with 2, it is success, meaning we got the data. Okay, this is the response that we got. Okay, it is in the JSON format, and in JSON format everything is just key value pairs. It starts with curly braces. It means that it is starting of the JSON object. Inside you find key value pairs. Okay, so the uniform constraint, the uniform interface constraint is satisfied. The statelessness is satisfied because, now we request the product data, right? Now the server does not keep track of, saying that, okay, this client requested for product. The server job is, it just receive the request and it sends the response. That's it. After that, client has no business with server until, it sends another request, right? Okay, it send it, it serves the layered system. It serves the client server approach. All the things that we talked about, we see how it is implemented in the OData service. Okay. Uh, Can you guys correlate, what we have discussed and what we have seen in terms of OData or RESTful API? Or do you have any questions? Okay. So uh, this is how you request the data from the OData services. This is, just publicly available. And now we will see what is the difference between when we request the data in XML format or JSON format. We will see what is the difference. Okay. Now, this fourth version of this Northwind OData service gives you only in JSON format. If you go to version 2, the same information is displayed in XML format. Okay. So, in the version 4 of the Northwind data, we used Northwind OData service. Okay. In version 4, it gives you response in JSON format. Okay. In version 2, it gives you response in XML format by default. Okay. Now let's say if I wanted to request it in the JSON format, I use this system query options. I will explain later why I am using it, but for now just remember it. I'm going to request by adding this to URL. I am requesting data in JSON format. Okay. So now I added okay, give me data in the JSON format. So now it gives me data in the JSON format. But why should I ask? Give me data in the JSON format. Okay. Let's see if I don't ask for in the JSON format. Let's say if I just I go to the developer tools from more tools. Okay. Okay. Now I just request the data in the XML format. Okay. If you see, it says that 1.1 KB, right? Products to XML format. Okay, it is 1.1 KB. Okay, let me just take the let me request the whole products. Okay, it is 4.1 KB. Okay, instead of requesting one, I just requested the whole thing. It is in 4.1 KB. Let me, you see the size here too, right? It is small, but it says, a column there size, which gives, the size of the JSON file that you received. Okay. Now, if sorry, the size of the file that you received in the XML format. Okay. Now, if I request in the JSON format, the same data that it represent, it just represented, the same information, products information, but if you see, it is 2.6 KB, right? Same products information. If I represented in JSON format, it is 2.6 KB. The reason being, when it is represented in the JSON format, it is less size is when you represent data in the XML format, you write lots of XML tags, which you could avoid in the JSON format. So if you see the size of the same information in XML versus JSON format, in JSON format it is at least like 40% less than when you represent the data in the XML format. Let's say when you are writing in mobile applications or when you are writing web applications, it gives you significant performance when you use JSON format. That's why most of the Fiori or UI5 applications uses JSON format. But you can expose data either in XML or JSON format, but we are going to use JSON format down the line when we develop UI5 or Fiori applications. Does that make sense? You have any questions?
No questions.
Um, since okay, today we discussed about OData. We discussed about RESTful API. In RESTful API, we discussed about two basic tenets. One is resource-based, and the other one is representation. In resource-based, we talked about everything we see in a OData or RESTful API is a resource. We are going to request the resource through URLs, and we are receiving, whenever you request a resource, we just receive the representation either in XML or JSON format. We discussed why JSON is popular when you developing web or mobile applications, because the same amount of the same information can be uh, in JSON format. It is less in size so that it gives you better performance. And we discussed about several constraints that a RESTful API should follow: uniform interface, cacheable, client server, layered system. So as long as it follows the basic tenets and the following, the discussed constraints, it is qualified to be a well-maintained or well-developed RESTful API. We see a publicly available OData service, how to request the data, how to request the data in JSON versus XML format, and we looked at pros and cons to request in several formats. I think that is it for today. Before we conclude, if you have any questions, just go ahead and ask.